Okay, so in this portion of the video here for diagnosing this 2012 Chevy Cruze ECO 1.4 liter turbo engine, this is where I'm going to show you with the engine running, and then I'm going to do some live data and look at a little bit of freeze frame data. This is just the basics, just to kind of cover our bases and just kind of give you an idea on what steps or what tools I use to diagnose this problem. So if you see here where I've drawn that X, you'll see where there's a little line I painted on there as well, and that's where the vacuum leak is. So you can hear it hissing. So if I plug it up, you see there. And I hear it running better. So anyway, what I want to do here is show you what the live data looks like before and after. So you can see here inside the car, the check engine light's on. This is the RPM gauge. It's not like going all over the place, but it's I hear the chugging and I feel the rattling inside the car. So I'm going to go to my quick, cheap, dirty little enhanced code reader here. And this just kind of gives me a little bit of information here, and easier than using the big guns, the big Autel scan tool. Shit, it just died. Alright, so let me restart it here. Just keep it running a little bit here, just kind of feather the throttle a little bit. So you can see here that MIL status, MIL means malfunction indicator lamp. It means the same as the check engine light. So it's on, so I'm going to go ahead and scan it. And I'm going to read the codes, and I'm going to read the current DTCs. DTC means diagnostic trouble code. So we've got 3 going on here, or stored in the computer's memory here. So we got one that's a P0176, manifold absolute pressure, barometric pressure circuit range performance, system 2 lean, P0171, and then this is a P1101, and I can put this in the description. I forgot off the top of my head what this one is, but I believe it's related to the lean running condition that we've got right now, because it's just sucking in so much raw unmetered air, meaning the mass airflow sensor isn't measuring. It's not going through the mass airflow sensors on this engine, so it's just kind of coming in without the knowledge of it. So anyway, so I'm gonna go back to I'm gonna go back here, and I'm gonna go to my my data stream, or live data, whatever you want to call it, and I'll just show you here. I'm going to select items, and I'll go to fuel status, and I'm going to go to short term, and I want to go to long term. Hell, we'll do fuel rail pressure too, and let's see, I think then I wanted to do bank 1 sensor 1 oxygen sensor. This is a narrow band, so 0.9 volts or 1 volt is completely rich, and then 0.1 or whatever or less is lean. So that I'm going to be looking at that as well. Okay, so it looks like it's not going to be see where it says fuel system, it says out of limits fault. So we need to see C.E.L. for closed loop. Closed loop is just a technical term in automotive that means that all of the sensors, the sensors that are in the engine management system are reporting data to the computer, and the computer's accepting it, and it's making corrections based on that. So anyway, but we're not in closed loop. We're in out of limits fault. and so I can't see my short-term, long-term fuel trim. You know, as you can see right here, when I diagnosed this earlier, I saw that the short-term and long-term was really crazy. So it was too high. It was adding so much fuel. So we can see that it's not a fuel pump problem. We see it fluctuating a little bit. That's just because of idle. It's just chugging because it's got that vacuum leak. So we see the oxygen sensor is full lean. It's full lean, totally. So I'm gonna exit out of the data stream or the live data, and I'm going to go to I'm going to go to my freeze frame. And this is really nice. When you get better, you can understand why freeze frame is important when you get better at doing diagnostics, or who cares, just you know, try to find the problem the other way without using freeze frame data if you're not a tech. So don't understand what is going on here. Let's try this again. I'm going to unplug it, plug it back in again. So I can have the engine off for this. So I'm just going to turn the key on to the second position to where all the lights turn on in the dash, and then so you don't kill the battery if the fan is on for the HVAC system or whatever. Turn it off, and I just hit this one time here, and it turns the lights off on this. This system here with Chevy uses these types of switches. So if you turn it to the full left one time, just like turn it once all the way to the left one time to that part there, past auto to the left, then it will just turn the lights off while the key is on. So the key is on, you see the lights on in the dash. So that's how you know that's the second position of the ignition switch. Anyway, so back to this. So I'm gonna go back to here and read codes and current DTCs, and then let me go back to here, go to freeze frame. So that's what I wanted to go look at. So I'm going to look at the freeze frame. So with all the shakiness, okay, so this is 1 of 7. So this is a snapshot at the time the fault occurred, and the computer just took a snapshot of all the live data while it was making it at the time when the computer found a fault with something. So this is past. This is like, you know, whenever the problem started, and so this is not real time. All right, so this is just what the computer saved. So basically looking at here is DTC that caused the required freeze frame data was P0171. C.E.L means the fuel system was in closed loop. It wasn't really going very fast because the calculated load was low, or the acceleration or the load of the engine and transmission. It wasn't like pulling on a hill or, you know, going up a hill or anything. So short term 28.1%, long term 34.4%. That's plus. That's adding fuel. Fuel pressure was 43. Intake